So we're trying to find the area of a trapezoid. Find the formula. What? Oh, isn't school over already?
Trapezoid
area is equal to 1/2. It's the same as the area of a triangle, but except I have two of them. So if I have two triangles with the same height, I have two different bases. Okay, so I have B1 plus B2. Okay, and then I have to multiply that times the height. So in this case, here's B1, here's B2. So I have 1 and 3. So I'm going to take my formula and rewrite it down here. Now, most of you didn't do it all fancy like this, but you figured it out. So my base, first base is 1, and my other base is 3. And my height is this piece, the x-axis. Okay? Yep. Yep.
How is the second base 3?
So you have to take this trapezoid and think of turning it. Okay, so here's my first base, here's my second base. And then here's my height. The height connects the bases. Okay? You're used to seeing a trapezoid this way. So if you could envision this trapezoid like this, here's base 1, which is 3, here's base 2, which is 1, and here's the height, which is 1. Okay? All right. So 1/2 of 1 plus 3 times 1 is 2. Okay? Good news is I've got one that looks just like that right here. So do I have to calculate this again? No. Okay. What I do have to calculate is this one here and all the other pieces. But really, I only have a few unique pieces. I've got one here because I've got a matching one over here. So 1 and 2 go together. I've got another one here, but I got a matching one here. So those 3 and 4 go together. I've got another trapezoid here and another one here, but those go together. And that ain't no trapezoid in the middle. What is it? This is a rectangle. So do the rest of them. Make that your denominator, and the numerator is still 2. So we had that 2. But really, how many 2's are there? 2 of them. So we got 2 times 2. So that's for number 3 and number 4. We've got this itty-bitty triangle on the left, but if I take that triangle on the left and put it together with the triangle on the right, I no longer have 2 triangles. I have a square, which is a 1 by 1, which means the area is 1. So now I've got 4 and 5. Use the same process here. I've got 3 plus 4. Then I have to take a half, but then I have to double it. So 3 plus 4, half and doubled is just 3 plus 4, which is 7. Okay? And last but not least, I've got my rectangle, which is 4 units high, and that's 4. So add all that up, what do you get? 16. So I got 2 16ths, which means that sliver is 1/8. And we're going to be talking a lot about areas underneath the curve today. That's pretty much the last new stuff you're seeing for the entire year. So I want you to take a minute. We're going to skip this one. Go to the website load times, read through that. Okay, and then we'll talk a little bit more. Skip to 6.2 and go to 6.3. Nobody in third period stopped me when I was getting all fancy with the picture over here, when they should have just told me, hey, look, where are all the numbers? They're in the table. I made this very complicated, but I was also having hot flashes and we're getting dizzy third period, so that's my excuse. I'm feeling better now, so we'll be okay. All right, so each of these relative frequencies is really n what? What did we just do? Area, okay? And if we add up all of these, what number we get? 1, okay? That hasn't changed since yesterday. So now all we're doing is we're going to be answering questions. We have to look very carefully and see the mean time is 3 seconds, which makes sense because that's in the middle. Okay. And our standard deviation, and this is kind of standard, if you will, whenever you see a histogram like this that we can convert into a normal distribution, that the distance from one rectangle to the other is half a standard deviation. So notice these are not 0.4 apart, they're 0.2. And this is going to make a little bit more sense as we work through standard deviations. Okay, so now you have all the knowledge you need to start answering these questions. Said, first of all, is this a good model? Why? What are the 2 reasons? Look at the picture. It's symmetric and it's bell-shaped. Okay, so anytime you have a set of data that is symmetric and bell-shaped, we are going to convert that into a normal distribution. Okay, so it's symmetric and bell-shaped. Okay, so it says, what proportion of the websites loaded within 1 standard deviation of the mean? So here's what you got to do. You got to go back up here. I'm going to use my drawing tool. I'm going to use, let's see, yellow should contrast nicely. So here is 1 standard deviation. That doesn't look that great. To the left, all good. And 1 standard deviation to the right. So when it says within, how many directions do we have on a horizontal axis? 2. So 1 to the left and 1 to the right. So what we really need to do is find the areas of these, just add them up. That's it. All we're going to be doing is adding and subtracting today. Can you handle it? Adding and subtracting? Liars. All right. So from 2.6 to 2.8. So I go 2.6 to 2.8. That's this one. 2.8 to 3. That's this one. And this one and this one. So add up those 4 areas, and that is all the area within 1 standard deviation of the mean. So go ahead and do that. Yeah. 0.95. 0.95. Guess what? That 0.68 never changes. This one will never change either. Okay. So 0.95. So 95% of all of these load times will fall within 2 standard deviations. Okay. It says what proportion loads within 1 standard deviation of 1 or 2.8 seconds. So I'm going to take my markup tool. So 2.8 seconds. Did we say 1 or 2? I'm sorry. What did they say? 1. Okay. So I'm going to go to my yellow markup tool. So here's 2.8. So it's these 2. And then these 2. Okay. So add those 4 numbers. So 0.0910, 0.1555, 0.1861, 0.1938. Add those up. And that will be your answer for the next one. Add those all up. 0.63. Okay. So it says compare the proportion of websites within 1 standard deviation to the proportion of websites with the standard deviation of the mean number. They're not the same. Why? Because I didn't use the what? What's the mean? It's 3. And my number that I used here was 2.8. Is 2.8 the mean? No. Okay. So, keep turning this off at the wrong time, don't I? Nope. There we go. We're still recording. Awesome. All right. So, in summary, we're looking at areas. And the good news is, once the normal distribution, these areas will never change. What I want you to do is take the normal distribution curve that's always going to be there, and I want you to put this somewhere in the notes. Hey, right there in the bottom. Here's what you're going to do. Open a new tab. type in normal distribution probability. And then it's Google, so we have a choice for images, and we want an image. Okay. So normal distribution probability, and I want you to look for the one that looks like this that says the empirical rule. I'll give you a minute to get caught up. Okay, just like we did for our Desmos graphs. So grab, pull, and drop. Okay? Hey,
Oh, sorry.
remember microphone.
Sorry.
All right. So, look carefully. This is the last new stuff you will learn in this class. Okay? When it's a normal distribution, here I have a mean of 1150. I have a standard deviation of 150. So you can see plus 1 SD means adding one standard deviation to the right. So that's 150. If I had another 150, that's 2 standard deviations. If I had another 150, that's 3 standard deviations. Remember what I say, if we have a left, there's also a right, so means we subtract. Nice. Thank you. We're recording this for perpetuity. Yeah, Diana, that was Shane farting right now.
Whoa!
Oh, okay, sure.
Shane, why are you turning red?
It's going to be out there on the internet forever. All right, so, see these numbers? Listen, these numbers never, ever change. Remember we got that 68%, or that 0.68 in the last problem? Hey, where do you think we got that? Because 34 plus, and then what's 13 and a half plus 13 and a half? God. And then I add it to 68 and I get 95. So if I go one more standard deviation, see how slim this is? It's teeny tiny. It's only 2.35%. So it's 2.35% times 2. 4.7, and you can tell this was done overseas. Why? What's between the 97, 99, and a 7? It's a comma. They actually use periods as commas. Very confusing. I don't know how they understand that overseas. Okay? Can we go more standard deviations? Yes. Okay, ready? For those of you that want to make big money in business, listen. How many sigmas to the right? How many standard deviations? How many to the left? What is 3 plus 3? There is something in business called Six Sigma certification. And here's what it means. Remember I talked about manufacturing? So if you are manufacturing stuff, and the stuff that you're manufacturing has a 99.7% of being a product that you can sell and not have any issues with, that is called Six Sigma. That means the toleration of that is so small, or your standard deviation so big that everything falls between 99.7%. So that means only like 0.3 customers, that's 3 out of every 1,000 are going to have issues with your product. Normally that's pretty good. The only time that's not going to be good is what? You're manufacturing stuff that is critical to life. Okay? So if you're a heart surgeon and you're using very finely tuned, calibrated instruments, you want to make sure that whoever made those really know what they're doing, because they're now going inside of a body. Okay, so it's either going to be measuring things, or you're cutting stuff, or you have to pry stuff open. You want to make sure that stuff works all the time. Oh, sorry, my forceps don't work. Can't clip off that artery. So sorry, you're dead. Okay, so medical instruments, very precise. That's why that stuff is really expensive. Okay, so anything that's going to require high degree precision, you're going to need more than 99.7. You're going to need like 99.99. Okay, but most everything else, not so much. So you need to know this, because we're going to talk a little bit more about this tomorrow. So go ahead and do the cool down. We're going to revisit this tomorrow. The cool down's not too bad. Tomorrow's is even easier.